Welcome to this Robpod Studio training course, HMI Designer, DRL Scripting for Doosan Robotics. In this tutorial, we will develop a custom HMI panel for a polishing application running on Doosan Robotics Dart platform. We will use HMI Designer to develop a simple panel to let users set up a polishing operation. During this tutorial, we will use DRL Scripting to develop the robot program. Basic knowledge of Python programming language is suggested. Let's begin. Open Robpod Studio, right-click on Project folder and create a new HMI panel file. Choose a name for the file. The HMI editor will open. Click on the panel top bar. In the side panel, choose a title for your panel. Also choose and add your logo to the top bar of the panel. We will now add UI components to the panel to design our polishing application. Add an image component to the panel. Choose from the file system the image file you want to display. Adjust the image size and position as you like. Add a pose component to the panel. We use pose component to let users choose and save robot positions. Change the label on the pose component. This will be our starting point on the serpentine path. Now add other pose components, one for each corner of the path. These will be point B, point C, and point D. Given those 4 robot positions chosen by the user, our application will calculate the serpentine path to polish the underlying surface. You can activate the snap function to better align the UI components. Add a label to the panel. We use labels to display fixed text information. In this way, we will give the user the possibility to choose the length of the advancement step during the serpentine path. So now add an input component to the panel. Inputs are used to let users set or change values, in this case the step length. Use the copy and paste function to duplicate HMI components and keep their visual formatting. Add another input component that we will use to let users decide the blending radius used during the path. For the polishing application, we will use force control, so let's again duplicate the label. Then add also a slider component to the panel. Slider are used to let users choose a value inside a fixed range. In this case, we will use the slider to choose the target force to be applied during the polishing action. Add another image to the panel that we will use to display a Doosan Cobot. Adjust the image size and position. Now add a button component to the panel. Buttons are used to trigger actions. We will use this button to start the polishing operation. Change the button label and choose an icon. Finally, add a monitor component to the panel. Monitors are used to display dynamic data. We will use this monitor to show the actual contact force during the polishing operation. Adjust color and text formatting as you like. Before proceeding, if this is the first time using Robpod Studio with a certain robot, you need first to install the Robot plugin. Go to Tools and download the Robot plugin. Then go to the Doosan Dart platform and install the Robot plugin module. When installation is completed, open the Robpod app. When you see the message, Synchronization Ready, it means that Robot is ready to be connected to Robpod Studio. So go back to Robpod Studio and connect to the robot specifying the robot IP address. To see how the HMI panel will look like on the Robot Teach pendant, you can use the Preview function. Select Robot as target and click on the Preview button. The HMI preview will appear on the Robot Teach pendant. Remember that this is not a working HMI, but just a graphical preview. Now that we have designed the HMI panel, it's time to develop the robot program using DRL Scripting. Right-click on Project folder and create a new DRL script file. Choose a name for the script file and then the DRL editor will open. Let's start defining the path corner points as Cartesian pose variables. Use posex function to define Cartesian variables. Our pose variables will be called point A, point B, point C, point D. In this tutorial demonstration, we are using global variables to define the robot positions. In a real-case scenario, it would be better to define those variables as system variables inside the robot task editor. System variables always keep their last values, and store their values even after the robot program is stopped. On the HMI panel, we should now link these variables with the UI components. Select the first pose component and find the variable section in its properties. Specify the name of the variable. It must be exactly the same variable name used in the DRL script. Then specify the type of the variable. As we are using Cartesian pose, select Tool Pose Type. Repeat the same linking procedure also for the other pose components. Now define in the DRL script the other variables used in the HMI panel. The step between different passages of the serpentine path, the blending radius, and the target force used during the force control. Link these variables to the HMI components. Select the input component, go to its properties and specify the step variable. Choose integer type. Select the other input component and link the radius variable. Choose integer type. Select the slider component and link the target force variable. We will now define a set of DRL functions that we will use to develop the polish operation. The Activate Tool function is used to turn on the polishing tool using the robot controller digital output. Specularly, the Deactivate Tool function is used to turn off the tool. The Start Force Control function is used to enable the active force control on the robot. Force is applied using the tool as reference frame. The force will be applied along the Z direction, using the target force value chosen by the user. The End Force Control function is used to stop the force control action and go back to position control. Now let's define the Move Serpentine function that will be responsible to implement the motion trajectory of the robot along the path. Don't worry about the code. You can find the whole DRL script in the resources section of this Robpod tutorial. Now we have all the elements to implement the polishing operation. So let's define a polish function. Use HTrans function to calculate an approach position above point A. Enable the force control. Activate the polishing tool. Then perform the serpentine motion. Turn off the tool and stop the force control. Calculate a retract position. Perfect. Now our polish function is ready to be linked with the Start button. Select the button component. Inside its properties, find the Action section. The display name is the message that will be displayed to the user when the action is being executed. In the command property, set the name of the function to be executed when the button is pushed by the user. The polish function in our case. The polish function contains motion commands, so it must be executed in the main scope. Finally, we need to link the monitor component. Monitor components can be linked to variables or expressions. In our case, we will use an expression to read the current force applied on the tool. Choose float as variable type. We can improve our polish function adding a home movement. To teach the home position, we will use Robpod Live auto-completion feature. Once connected, just move the robot to the target position and start typing the commands. The current robot position will be automatically suggested. Now, very important step. Before executing the robot program, we must first synchronize project files. Synchronize the DRL script. When using synchronization, remember to keep the Robpod app open on Robot Dart platform. Then synchronize the HMI file. Synchronization procedure is needed to transfer project file from your PC to the robot controller. Perfect. Everything is ready to compose the robot task. Open a new task inside Dart Platform Task Editor. In the commands list, find the Robpod section and add a script command block to the task. Open the script properties. Select the polish script that we have just synchronized. Click on Confirm. Back in the command list, find the HMI command. Add the HMI command to the task. Inside the command properties, select the polish HMI file. Click Confirm. Finally, everything is ready to execute and test our polishing application. That's it. Our custom HMI panel is ready. Users can change the polishing parameters, as the serpenting step, the blending radius, and the target force. Our users can also easily teach a new polishing path using the 4 corner positions. Use robot manual guidance to teach point A. Acquire and save the position on the HMI. Now teach point B. Move the robot to the desired position. Acquire and save the position on the HMI. Proceed with point C. Finally, teach point D. Now that all 4 points have been taught, users can start the polishing operation. To wrap up, in this tutorial we've walked through designing a custom HMI panel for a polishing application using Robpod Studio. We created the interface with the HMI editor's intuitive drag-and-drop tools, developed the robot program using Doosan DRL scripting language, and integrated everything within the Doosan Dart platform, delivering a flexible and user-friendly solution for robot operators.